Welcome to today's teaching. I'll be learning number basis. We have different number basis system. We have binary system. When we talk of binary system, we talk of base 2. Then we have octal system, that is base 8. We have denary system, base 10. Then we have duodecimal, base 12, and hexadecimal, and so on and like that. Then we have conversion from one base to another, and we have different rules in solving problems under these conversion problems. Like, for example, converting from base 2 to base 10. The rule number 1 is to multiply each number by the power of the base. Conversion from base 2 to base conversion from base 2 to base 10. Rule 1. Conversion from base 2 to base 10. Here, we multiply each number by the power of the base, that is 2. For example, convert 101 in base 2 to base 10. We go with this rule 1. We multiply each number, that is, we label from the back. Solution. Write the number 101 base 2. You label from the back, then you start with 0, 1, and 2. What are we going to have? We are going to have 1 multiplied by 2 raised to power 2 plus 0 multiplied by 2 raised to power 1 plus 1 multiplied by 2 raised to power 0. And you remember, any number raised to power 0 is 1. This one will give us 1 times 2 raised to power 2. That is 2 times 2. That will give us 1 times 4 plus this one will give us 0 times 2 plus, like I said earlier, 2 raised to power 0 is 1. 1 times 1 will give us 1 times 1 will give us 1. 1 times 4, 4 plus 0 multiplied by any number is 0 plus 1. 4 plus 0 is 4. 4 plus 1, that is 5, base 10. Then you can also convert rule number 2 from base 10 back to base 2. From base 10 back to base 2. What do you do here? The rule says you divide. Divide by the base given. Now 5 in base 10. For example, you want to convert it back to base 2. Back to base 2, you divide by 2. That is rule 2. Rule 2. Divide conversion from base 2. From base 10, to base 2. Divide by the base required. Repeatedly. And pick the remainder. Pick the remainder from downward, upward. What to upward. For example, that 5, for example, convert 5 base 10 to base 2. We want to get that number back to base 2. Going by the rule, we divide by 2. Solution: 5, 2. 2 in 5, that is how many times will 2 go in 5? It will go twice. Then it will leave a remainder of 1, remainder 1. 2 can also go in 2, 2 in 2, that is 1, remainder 0. Then 2 in 1, that is 0, remainder 1. You now read from that rule, you read upward. That means, therefore, 5 base 10 is equal to 101 base 2. We have gotten that back from base 10 to base 2. That is rule number 3. Decimal part, conversion of decimal part. Of number bases. In the case of base 2 to base 10, from base 2 to base 10, we multiply by the respective power. That is, conversion of 101, let's have 111.101, that is in base 2 now, to base 10. This old part will follow the normal rule, that is 0. So solution: 111.101, that's 101 base 2. We follow, that is 0, 1, 2, minus 1, minus 2, minus 3. Therefore, we are going to have 1 multiplied by 2 raised by 2 plus 1 multiplied by 2 raised by 1 plus 1 multiplied by 2 raised by 0 plus 1 multiplied by 2 raised by minus 1 plus 0 multiplied by 2 raised by minus 2 plus 1 multiplied by 2 raised by minus 3. Here we are going to have 1 multiplied by 4. 2 raised by 2 will give us 4. Plus 1 multiplied by 2 plus 1 multiplied by 1. 2 raised to power 0 is 1. Then plus 1 multiplied by, the interpretation of this in mathematics is the reciprocal. That is 1 over 2. That means we are going to have 1 multiplied by 1 over 2 plus 0 multiplied by 1 over, that negative sign is telling us that it's 1 divided by 2 raised to power 2 plus 1 multiplied by 1 over 2 raised to power 3. So 1 multiplied by 4 will give us 4. Plus 1 multiplied by 2 will give us 2. Plus 1 multiplied by 1 will give us 1. Plus 1 multiplied, this one will give us 1 over 2. Plus anything multiplied by 0 here will give us what? 0. Plus 1 multiplied by 2 raised to power 3 means 2 raised to power 3 means 2 raised to power 3 means 2 times 2 times 2, and that will give us 8. 1 over 8. Now the whole part, we first add up the whole part. 4 plus 2, that is 6, plus 1, 7. Then we take this one is having LCM. The LCM here is 8. We take the LCM. What is LCM is 8. How many times will 2 go in 8? That means it will go 4 times. 2 multiplied by 1 will give us, 4 multiplied by 1 will give us 4, plus 8 into 8 will go 1 time, then 1 multiplied by 1 will give us 1. Therefore, we are going to have 7 whole number. 4 plus 1 will give us 5/8. Then this one can also be expressed as decimal point. That is, how many times? That's 5/8. That is, 5/8 will give us 0 point. Add 0 to this. How many times will 8 go in 50? That is 6 times. 8 multiplied by 6. That is 48. Then it will leave a remainder of 2. How many times will 8 go in 20? That is 2 times, remainder 4. How many times will 8 go in 40? That is 5. So our final answer is 7.625. That means we are going to have our final answer now will be 1 point, that is 101.101 base 2 is equal to 7.625 base 10. Then rule number 4. When converting the decimal conversion of decimal part of number bases, that is from base 10 now to base 2. From base 10 to base 2, we want to conversion from base 10 to base 2. Talking about the fractional part. For example, we want to add this one back to base 2. This one is in base 10. Example. Convert 7.625 in base 10 now to base 2. What do we do? The rule says that you first divide this, follow the normal rule, divide by 2, you multiply the decimal parts by the required base. Solution. 7. Let's first divide 7. The whole number part, that is the rule. The whole number part divided by 2, you multiply the decimal parts, you multiply by the required base. 7, that will be 3, leaves a remainder of 1. 2 in 3, it will go 1 time, then leaves a remainder of 1. 2 in 1, that will be 0, remainder 1. So that means that 7 that is in base 10 is equal to 111 in base 2. Now the fractional part, we have it as 0.625, that is in base 10. Remember that I said since it's going to base 2, you multiply by the required base, which is what? 2. Multiply by 2. You repeat this. In the case of division, we read upward the other time here. But in the case of this one, we read downward. 2 multiplied by 5 will give us 10. Write 0 and keep 1. 2 multiplied by 2 will give us 4, plus that 1, 5. 2 multiplied by 6 will give us 12. We keep 1. 2 multiplied by 0, let's put our decimal point here. 2 multiplied by 0 is 0, plus that 1. Bring our 1 here. Then we repeat the same, we repeat it twice. But it is better to repeat it 4 times. 2, you multiply it by this, respectively, repeatedly. 2 multiplied by 0, 0. 2 multiplied by 5 is 10. We write 0 and keep 1. 2 multiplied by 2, that is 4, plus 1, 5. Put our decimal point. 2 multiplied by 1 is 2. but we are multiplying in that same number, in that same base. So we are not going to write 2. You look at it, divide it by 2. 2 multiplied by 2 is 2. How many times will 2 go in 2?
All right, so let's go.
Good day, students. You're welcome to today's teaching. Today we'll be looking at number bases. We have different types of number base systems. We have the binary system, talking of base 2 system. We have the octa system, base 8. We have denary system, base 10. We have duodecimal, base 12. We have hexadecimal, base 16, and so on and so forth. So, and we have conversion for one base to another, and we have different rules in solving them. Rule 1, conversion from base 2 to base 10. Conversion from base 2 to base 10, we multiply each number by the power of that required base, which is base 2. For example, convert 101 that is in base 2 to base 10. To base 10. How do we solve this? Going by that rule 1. Solution. You need number it from behind. So we number it from the back, and we start with 0, 1, 2. Now the 1 multiplied by the base raised to power 2 plus 0 multiplied by the base raised to power 1 plus 1 multiplied by the base raised to power 2. Any number raised to power 2 is 1. That will be 1 times 2 raised to power 2 means 2 times 2, which is 4, plus 0 multiplied by 2 plus 1 times 1. 1 multiplied by 4 will give us 4. 0 multiplied by 2, as a matter of fact, you know that 0 multiplied by any number is the same thing as that 0. Plus 1 multiplied by 1 will give us 1. 4 plus 0 is 4. 4 plus 1 will give us 5. That means 5 base 10. 5 base 10. That is, therefore, 101 base 2 is equal to 5 base 10. Rule number 2, conversion from base 10 to base 2. Here, we divide by the required number, the required base number. Rule number 2, conversion from base 10 to base 2. We divide by the required base number. For example, we want to convert from base 10, 5 base 10, back to base 2. Example, convert 5 base 10 to base 2. Solution. Like I said the other time, the rule says divide by the required base number. And what is the required base number? Base 2. 5, 2. How many times will 2 go in 5? That is 2 times. It will leave a remainder of 1. 2 in 2, that is 1. It will leave a remainder of 0. Then 2 in 1, that will be 0. Remainder 1. We now read the remainder upward. That means that 5 base 10 is equal to 101 base 2. Then we also have conversion in decimal parts, from decimal parts. That is, like if we have conversion from base 2 that is in decimal parts, we multiply by the repeated power of the base. What do I mean by that? For example, convert 101.101 that is in base 2 to base 10. Solution. One 1.101 base 2 is. Now we are going to label. You start from here, the whole fraction part before going to the decimal point. 0, 1, 2. This you start with -1, -2, -3. And what are we going to have now? That will be 1 multiplied by 2 raised to power 2 plus 1 multiplied by 2 raised to power 1 plus 1 multiplied by 2 raised to power 0 plus 1 multiplied by 2 raised to power -1 plus 0 multiplied by 2 raised to power -2 plus 1 multiplied by 2 raised to power -3. 1 multiplied by 2 raised to power 2 will give us 4. Plus 1 multiplied by 2 will give us 2. Plus, remember that anything raised to power 0, it will give us 1. 1. 2 raised to power 0 is 1. 1 times 1, 1. Plus, the meaning of this -1 over 2, 2 raised to power -1 is 1 over 2. That is the interpretation. The interpretation of that. Plus 1 multiplied by 1 over 2, which will remain as 1 over 2. Plus, as a matter of fact, you know that 0 multiplied by any number will remain as what? 0. Plus 1 multiplied by 1 over 2 raised to power 3. That means we are going to have the whole part will give us 4 plus 2, 6 plus 1, 7. Then the other part, you discover we have LCM. 2 raised to power 3 here will give us 8. 2 raised to power 3 here will give us 8. Okay, 8 and 2. What is the LCM? We have it as 8. Here we give us 1 over 2 raised to power 3 is equal to 8. That means we're having 8 as the LCM. 2 in 8 we go 4 times. 4 multiplied by 1, 4. 8 in 8, it will go 1 time. 1 multiplied by 1 will give us 1. That means we are going to have 7. 4 plus 1, 5 over 8. This one can also be written as that 5 over 8. We can change it to decimal fraction. How many times will 8 go in 5? As a matter of fact, it cannot go in 5. You write 0 point. Bring 0 back to that 5. It will give us 50. 8 in 50, that is 6 times. 8 multiplied by 6, 48. It will leave a remainder of 2. It will leave a remainder of 2. Then that means we bring 0 to it. 8 multiplied by 8 in 20, that is 2. Then 8 in, it will leave a remainder of 4. 8 in 40, that will give us 5. Therefore, 101.101 base 2 is equal to 625 base 10.
All right, sir.
Let's look at the next question under equations in a number basis. For example, 126 base n is equal to 86. The question is find the positive number of n, the positive number of n. Solution. So we number as usual 0, 1, 2. Okay, we leave this one. It's in base 10 already. So that means we are going to have 1 multiplied by n raised to power 2 plus 2 multiplied by n raised to power 1 plus 6 multiplied by n raised to power 0 equal to 86. 1 multiplied by n raised to power 2 is n raised to power 2, that is n squared, plus 2n. n raised to power 0 here is 1. 6 multiplied by 1, 6 plus 6 equal to 86. That means we're having an equation now. We collect like times. First, that will be n squared plus 2n equal to 86. When this one goes, it becomes what? Minus 6. That means we are having n squared plus 2n equal to 80. Now, this n squared is showing quadratic equation of this form: x squared plus bx plus c, which is equal to 0, our quadratic equation. That means we're having n squared plus 2n minus, this one is positive here, comes inside, it becomes negative. 80 equals what? 0. We now solve this by factorization method. We can also use quadratic formula, but let's use factorization method. You remember in factorization, we say a multiplied by c is equal to ac. What is our a here? The coefficient of this one, which is what? 1 multiplied by minus 80, the constant term, and that will give us what? Minus 80. What do we do with this? We look for two factors of minus 80. That when you multiply, will give us minus 80, and when you add, will give us plus 2. And what are the two numbers? We look at 10 and 8. But the sign is not there yet. We need to look at 10 multiplied by 8 will give us 80. But we don't have ordinary 80, we have minus 80. So that means one we carry positive, while the other we carry negative. Then we need to consider this number, that when we add, will give us this. So that means we are going to have 10 minus 8. 10 minus 8 is like when you are having 10 naira and you are owing 8 naira. When you pay your debt, you will still have 2. 10 multiplied by minus 8 will give us minus 80. We now substitute this value as 10n and then minus 8n. Therefore, we are going to have n squared plus 10n minus 8n minus 80 equal to 0. We factorize by grouping. What is common here? N. That means we have n into bracket n into n squared, we have n, plus n into 10n, we have 10. What is common here? The common factor here is 8 into 8n, we are left with n, minus multiplied by minus, will give us plus. 8 into 80, we have 10 equal to 0. Now the interpretation is n minus 8 into bracket, you pick one of these two, n plus 10 equal to 0. That means n minus 8 equal to 0, or n plus 10 equal to 0. The interpretation of this is, this one will cross this line, that means n is equal to 8, or n is equal to minus 10. Now look at what we have done here, n is equal to 8 or n is equal to minus 10. Number bases cannot be in negative form, so we discard this negative and we pick this positive. Therefore, the final answer, because even from the question says find the positive number. So n is equal to 8. So what we've done. Now we are going to look at the equation leading to simultaneous equation. I mean number basis leading to simultaneous equation. For example, determine the number basis x and y in the following simultaneous equations. 32 base x minus 12 base y equals to 9 base 10. And 23 base x minus 21 base y equals to 4 base 10. Solution. The first one is 32 base x minus 12 base y equals to 9 base 10. This is equation 1. The next one is 23 base x minus 21 base y equal to 4 base 10, equation 2. In this question, that will be 32. Let's first deal with that equation 1 minus 12 base y equals to 9 base 10, which is our equation 1. Now we expand. Conversion to base 10 is expansion. 0, 1. So that means we're having 3 multiplied by x raised to power 1 plus 2 multiplied by x raised to power 0 minus, remember to put this one in brackets so that it will not affect your workings. So 1 multiplied by y raised to power 1 plus 2 multiplied by y raised to power 0, close the bracket, equal to 9, which is in base 10 already. So we take this one, okay, which is already in base 10. 3 multiplied by x raised to power 1 is 3x plus x raised to power 0 is 1. 2 multiplied by 1 is 2 minus 1 multiplied by y will give us y. Minus times plus will remain as minus. So y raised to power 0 is 1. 2 times 1, 2, which is equal to 9. What do we do now? We collect like times. So that means we're having 3x minus y plus 2 minus 2. As a matter of fact, plus 2 minus 2, you have 2 naira, you are owing 2 naira. If you pay your money, you don't have anything. So that is 0, equal to 9. So we take this one to be equation 1a because it's under equation 1. Then the next one, which is equation 2, 23 base x minus 21 base y equal to 4 base 10. This one is equation 2. We repeat the same step, what we have done here. So we expand this. That is, we convert to 10, to base 10. So that will be 2 multiplied by x raised to power 1 plus 3 multiplied by x raised to power 0 minus into bracket 2 multiplied by y raised to power 1 plus 1 multiplied by y raised to power 0, close the bracket, equals to 4. Now 2 multiplied by x will give us 2x plus x raised to power 0 is 1. 3 multiplied by 1, 3, minus 2 times y will give us 2y. Minus times plus will give us minus. 1 times 1 will give us 1, equal to 4. Now we are going to have 2x minus 2y equal to 4. This one is positive here. It becomes negative. Minus 3 plus 1. That means we are going to have 2x minus 2y equals 4 minus 3. That is 1. 1 plus 1, 2. We are going to have 2x plus 2y equal to 2. You now discover that in this equation, 2 is common. We can divide to make our work more easier. We divide by 2, 2, divide all through by 2. This one will go, we cancel this. That means we are left with 1 here. Then 2 into 2x, we have it as x plus y equals to 1. That is equation 2a. So that means the required equations are 3x minus y, which is equal to 9, equation 1a. Then x plus y equals to 1, which is equation 2a. Now, we can use substitution method, simultaneous equation, we can use substitution method, we can use elimination method, we can use graphical method, even we can use matrix method. Let's use elimination method. Elimination method. In elimination method, we want to eliminate one variable. So here we subtract equation 2 from 1. Subtract equation 2 from 1. What is the interpretation of that? That means that is 3x minus y equals to 9, which is equation 1a. Then we have x minus y, which is equation 2a. Now, what is the interpretation of this? You are subtracting equation 2 from 1. So minus here. 1 minus 9 will give us 8. 1 from 9 will give us 1 from 9 will give us 8. Then minus y, that is minus y minus y. That means it will give us minus y, minus times minus, plus y. So minus y plus y will cancel each other. So we are now left with x minus 3x. X minus 3x. And that means we are having 2x. We divide both sides by 2. Divide both sides by 2. Because we are looking for x. We divide by the coefficient of x, which is 2. 2 here, 1, 2 here. So 2 here, 1. 2 in 8, 4. Our x is equal to 4. Now we want to look for y. We want to look for the variable y. So, to get variable y, we substitute x as 4 in any of the two equations, either equation 1 or equation 1a or equation 2a. Substitute x as 4 in, let's use equation 2a, in equation 2a. And what do we have in equation 2a? We have x minus y equal to 1. That is what we have in equation 2a. So anywhere we see x, we write it as 4. That will be 4 minus y equals to 1. So we collect like terms now. That means minus y is equal to 1. This one is positive here. It becomes what? Negative here. So minus y is equal to minus 3. This is not y yet. We are having minus y. And we're having minus 3. So we divide both sides by minus 1. By minus 1. This one we cancel this. This one we cancel this. So y is equal to 3. So the two bases are 4 and 3. That is, x is 4, y is 3. So that means we're having 32 base 4 minus 12 base 3 equals to 9 base 10. And the second one, we're having 23 base 4 minus 21 base 3 equals to 4 base